Hey AP, I'm just going to do a brief overview for your remote day lesson. So today we're going to be working on some new concepts as well as reviewing some old concepts. So go ahead and get out your torque and rotational practice problems. We're going to look over questions 7 through 11, make sure you did okay on those. We're also going to be introducing a lesson today on angular momentum and impulse. We're going to be using Khan Academy to do this lesson. In this lesson, I want you to watch each of the videos and take notes based on the notes that they give you in Khan Academy. And I want you to aim to get a perfect score on the 4 different exercises that there'll be. Okay, so getting into today's lesson, you want to have your formulas handy, especially the torque and rotation formulas. We've got our supplemental notes. Those are always there to jump into if you need to. We haven't had everybody finish up the quiz yet, so the center of mass, simple harmonic motion, and rotational kinematics quiz, we're going to look at that next class. I just left it in here just to remind you of that. So we'll look at it later. As far as getting into this, open up your practice problems, and let's take a look at 7 through 11. And so notice this is the question that we did in class with the meter stick. Just check your work, make sure you did okay with that one. This is the one that we didn't fully do in class here. We practiced a problem that was like that, and this kind of just shows you the math, how to work through those questions. Both of these questions right here, you can expect to see those on our final exam coming up. So just make sure you're on top of that sum of torques situation, how everything balances in equilibrium. Similar kind of question right here, equilibrium situation with a hanging sign. The next question was asking us to look at Newton's second law and look at rotation. Notice how we were using multiple formulas, but it's coming from the basic idea of Newton's second law of torques. Torque equals moment of inertia times angular acceleration. And notice how I just substituted torque equals Fr. I substituted it, moment of inertia equals some ratio times mr squared. Put that in there. Angular acceleration equals change of angular velocity over time. That was just all subbing in all these different formulas together into one, solving for force in this case, and then solving for radius in this case. So there's your work on that to see how that worked out. All right, next thing we're going to do then is we're going to be introducing this next topic here with angular momentum and angular impulse and conservation of angular momentum. So for this lesson, I want you guys to, again, watch all the videos and take notes in your journal. Review each review sheet, and I went ahead and just posted them to the upcoming slides in addition to what's in Khan. And then make sure to work on your 4 exercises with the goal of getting a perfect score in each one. So as far as angular momentum and angular impulse, I went ahead and defined the key terms here. So notice angular momentum is like regular linear momentum. That one had the letter P. We give this letter L. And then we also have this idea of change of momentum right here. So notice change of L. And just like the impulse momentum theorem that we went over in the unit on momentum and impulse, when you have an impulse will equal a change of momentum. Here we have an angular impulse, which is defined as torque times time, is equal to a change of angular momentum. Okay. Then notice we also have this idea. So here is what momentum equals mass times velocity. Remember that? This is angular momentum equals moment of inertia, which is like mass, times angular velocity, right? So the same basic idea. We've got our impulse momentum theorem down here. And then we also have this idea that we have a torque, and so this is using some substitutions in here to find out where we've got our radius involved here. But notice here that the angular momentum, mass, and velocity right here, and this kind of shows you this idea of change of momentum with a torque. So that taken forward, it gives you some notes here to read through here. But it kind of talks about like how like this ball that's flying upwards here just has mass times velocity. So we say it has linear momentum. But when it hits this stick right here, it's actually going to cause it to rotate. And so in the sense that this linear momentum is going to hit the stick, okay, that's where we can use this MVR right here to talk about how this can turn into angular momentum. So it's kind of a weird idea, but like the ball itself has linear momentum, but it also has angular momentum, even though it's traveling in a straight line, in the sense that it's going to hit that stick at a certain radius. Okay, and that's how it transfers that angular momentum, and that's how angular momentum will be conserved in our next one. So you're going to work on those ideas. So there's your formulas, but then that idea of conservation of angular momentum just says that angular momentum is always conserved. Gives you some ideas to think it through right here. And then it kind of relates it back to that problem we just looked at with the stick. So anyway, that's it. So once you get the lesson is basically down, go ahead and jump into those exercises, work through the exercises, and that'll be our lesson on angular momentum and impulse and conservation of angular momentum. When you're finished with that today, don't forget to do your attendance form. That's it. So you guys have a great day. Enjoy yourselves.